Okay, let's get started on differentiation from first principles. Okay, last time we learned about the average gradient, isn't it? Okay. Alright, so we said the average gradient was the average of the gradient between the point A and B, isn't it? Right? That's what we said last time. So what we're now going to be doing is to find the upper gradient of a curve is going to be difficult, but we can find the gradient of a curve at a certain point. Okay, so basically what this means is that if B is here, the closer I get to A, which means the smaller h becomes, the more and more I'm getting towards the value of A, right? That's what it means. So we have to make the average gradient as small as possible to find the gradient of a point at to find the gradient at the certain point, right? So basically what we're doing is we are minimizing the average gradient. We want it to become as close to zero as possible. What does that mean? That means this h has to become as small as possible, which means it has to be close to zero, right? So what we're now doing is that, do you remember, if you remember this formula without the limit, that's the formula that we found for average gradient, isn't it? Okay, so the smaller the x is, the more it's going to get to what we're going to call the derivative. So we're going to find the limit of this formula. Remember we talked about limits, right? So we're going to find the limit is h is 0. So basically we're asking ourselves, as h is becoming smaller, what is happening to this gradient, right? And that is what we call the derivative of f of x. That's why it's got a small thing in it, that's hyphen. Okay, it's a derivative, which means we are going to differentiate, right? And when we differentiate, that's how we find the gradient of a curve at a point. Okay, so the derivative of a function is written as f prime. We call this f prime of x, and the gradient at a point. So if you find the derivative, then we can always ask you and say, oh, okay, so what is the gradient of the curve at x equal to 2? You are now going to take what you found to be the derivative and substitute 2, and that's how you find the gradient at that point. Okay, right, so we're going to be doing more and more examples on that right now, but let's do this example here. Okay, so this one says find from first principles the gradient of f of x. So basically what it means is we're going to differentiate this. Okay, so to find the derivative from first principles, okay, we are going to have to remember our formula, right? So here's 1a, f prime of x is equal to limit as h approaches 0 of x plus h minus f of x divided over h. Okay, that formula is also there at the back of your question paper, so if you forget it, you can always check it out. It's there, but it's always good to just know these things. Alright, now how do we use this formula? Well, we're going to use the formula. One important thing, do not leave out this limit, because if you do leave it out, the penalize for that. Okay, so it's the limit. Now what is f of x plus h? When you take x plus h into place where there is x, right? So basically what this means is that this is 1 minus 3 by this x, I'm now putting x plus h. So it's 3 by x plus h to the power of 2. Okay, this is what f of x plus h is. Are we together? Okay, right, so where there is x plus h, you replace 2x there, right? Minus, well, the f of x, we already know what this is. It's 1 minus 3x squared. Okay, so we're gonna say 1 minus 3x squared. Okay, divide that whole thing by h. Right, now obviously we have to simplify this top part. So we're going to do that. This is the limit as h approaches 0 of 1 minus 3x plus h squared is the same as saying x plus h by x plus h. Okay, minus, okay, let's remove the brackets there already. You can remove now, you can remove next step, doesn't matter. Okay, obviously negative and the negative makes a positive 3x squared. Okay, all this over h. Right, now we have to do our binomial expansion here. You normally know it is FOIL.
Yes.
Okay, so we're gonna do that there. Okay, so that is the limit. This limit, you lose a mark, do not leave it out. Okay, 1 minus 3 by, okay, let's do the FOIL. So x and x gives you x squared, x and h gives you h plus x gives you x, h times h gives you h squared. Okay, minus 1 plus 3 squared. All of this is divided by h. Okay, simplify that thingy. So let's do that. So this is the limit is h approaches 0 of, okay, so let's simplify that. 1 minus 3 by x squared plus h, that's 2xh plus h squared minus 1 plus 3 squared. Okay, all of this is going to divide h. When we're done, the question is going to be 5-mark question. Okay, so one thing that you can just always remember that x plus h squared gives you x squared plus h squared. So once you just remember that this is equal to the two steps, you can skip. Okay, so just remember that this is always equal to that. Okay, you get to, so they will not give you marks for these two steps. Right. Okay, so let's go on to the next. Right, obviously now we need to remove our brackets so that we can simplify the whole thing now. So that's limit of as h approaches 0 of 1 minus, okay, so now we're going to multiply in there. So 3x squared minus 3 times 2, that's 6hx, 3h squared minus 1 plus 3x squared. All of this is over h. Right, like terms, okay. Negative 3 squared, 3 squares are gonna simplify to naught. 1 minus 1, okay, that's gonna turn to naught. So what do we have now? Okay, so negative 6xh minus 3h squared over h. Oh, sorry, there it is. Okay, now, well, you can divide each term by h or factorize h out, cancel them out, same thing still. I prefer to just say take the h out, not the 6 and the 3. Yeah, we know there's a common factor, but well, let's not kill ourselves for now. Okay, so you can take out h and have negative 6x remaining inside minus 3h remaining inside over h. They can cancel. Right, what limit do we now have to find? We now have to find the limit as h approaches 0 of negative 6x minus 3h. Now what happens here? This negative 6h is not affected because it counts as a constant, right? The limit is for h. So this negative 6x remains as is, but that one is going to become 0 because h is approaching 0.
I see, so I understand this. I get it.
Okay. Right, so now how do you find the derivative? Okay, we found our f prime of x to negative Okay, that's what we found. So now, what we're now going to do to find if x equal to -4, we're just going to find f prime of -4. Basically meaning where there's x, we replace with -4. And this becomes 24. So the gradient of this curve, 1 minus 3x squared, x equal to -4, is 24. So basically that's the gradient. If you draw a tangent at that point, that will be your gradient. Okay. And then part C, they're asking what is the gradient of the tangent to f at x equal to 5. Okay, so it is just great. So you take your derivative and replace 5 in it. So which means it's negative 5, which is equal to 30. Right. Second example, differentiate from first f equal to 1 over x. Same formula all the time. As long as you see this word differentiate from first principles, you know we are using this. Okay, I forgot to mention that. Okay, that's differentiate from principles, right? F of x plus h minus f of x over h. Okay, so let's do this. Limit as h approaches 0 of 1 over x plus h minus 1 over x divided by h. Now, this is where you will have to remember how to work with your common denominators. So we're gonna say the limit is h approaches not of 1. I don't put anything. The common denominator here is x times x plus h, isn't it? That's the common denominator there. Right. Principle of common denominators, by the way, works like this. If you take x plus h and divide it into this whole thing, you're gonna have x. So that's x minus. If you take and divide it into this whole thing, you're going to be left with x plus h. You multiply it with that 1 there, is the same thing, plus h. Okay. Now, what happens when you take a fraction and divide with the denominator? This denominator joins the other denominator there, right? Okay. So it becomes limit as h approaches not of. Okay, if we simplify this already, we're going to have negative h because x minus are going to cancel each other, and the negative and the positive leaves negative, over by x plus h. Oh, and then multiply with that h there already, which means they are going to cross each other out. Okay. And now you have the limit, as h approaches not of negative 1 over x by x plus h. Now should find, isn't it? Well, if h approaches 0, what's going to happen? This x end up multiplying because x plus 0 is x itself. So this x and that x are going to multiply each other and become x. So here's your answer, negative 1 over x squared. The h, because it approaches naught, so it tends to naught, doesn't count it. Alright, third example, differentiate from first principles g of x is equal to that. Okay, same. G prime of x is equal to the limit as h approaches naught of x plus h minus g of x. So it doesn't always have to be f. Okay, even g can be to be. Right. Now let's see how this is work out. Okay, so this is x to the power of 3, but remember we're going to replace x plus h. So x plus h to the power of 3 over minus g of x is just 2x to the power of 3 itself. Okay. No need for square brackets because it's just one term, so we can always just subtract it as is. Okay, now there we go. Right. X plus h to the power of 3 is the same as x plus h by x plus h squared. X to the power of 3 over. I think we know what this becomes, isn't it? This becomes h plus 2h, h plus h squared. So we're just gonna substitute that. Okay, so that's 2x plus h by x plus 2hx plus h squared, because we kind of discovered it before. Why should we expand again when we know? So let's just use that. Now, what we need to discover, if we multiply this by that, what comes out? Okay, so this is the limit as h approaches naught of 2 by. Okay, so remember how we expand this. We take the x, multiply with everything, right, and then take the h, multiply with everything in there. That's how we normally do it, right? Okay, so let's just do that. X squared plus hx plus h squared plus h by x squared plus 2hx squared minus 2x to the power of 3 over h. Okay, right, let's simplify that. So this is the h approaches 0 of 2 by. Right, let's multiply this in, so that's h to the power of 3 plus 2h squared plus 2h squared plus hx squared, okay, plus x squared h squared, x squared h, same thing, plus 2h squared x plus h to the power of 3 minus 2x to the power of 3. This is nicely long. Okay, all right, let me first multiply the 2 in there and then look for like terms. Okay, let me multiply the 2 in. So this is 2x3 plus 4hx squared plus 4h squared plus x squared, same difference, plus 4h squared x. Wait, is this not 4? No, this is 4h squared x. Okay, plus 2h3 minus 2x3 all over h. Oh, right. Now let's look for like terms. Any like terms? Okay, 2h3 minus 2x3, these ones away. Okay, now let's see what happens when you have the other like terms. 4hx squared, 2hx squared, so that adds up to 6hx squared, right? Yeah, this one and this one, they're like and this one, they're like terms, so they're gonna add up, right? 4h squared x, 4h squared x, these are right, so they're gonna add up. Mm-hmm. 2 times 2h x squared. There's 2 outside, still have to multiply in there. This one comes from h plus x plus h squared, gives us that. Okay, right, so that is positive 6h. And then this one, 4h squared x, 4h squared x. If you add them, it's 8 h squared x. Right, another like terms, okay, 2h to the power of 3 is on its own. All of this over h. Right, divide everything 1 by 1 by x, or fill out x and cancel them out, same difference. Okay, let's just do what we are used to. Okay, the h there, and if you take out the h, you've got 6 squared plus 8hx plus 2h squared over h. Cancel them out, and then if you are now taking the limit, is h approaches naught of 6x squared plus 8hx plus h squared. Right, now if h is approaching naught, then that means this is approaching naught, that is approaching naught, so you only left it 6x squared, and that's your answer. Okay.